Hello and welcome to today's video. It's our last lesson in the first right triangle unit, and by the end of this lesson we're going to discover how the Pythagorean theorem works to give us the distance formula on a coordinate plane, and then using the idea of the distance formula derive the equation of a circle from the distance formula. So now, when we look at the distance between given points, what we first always want to think about is where is the point on the coordinate plane. So we have -1, -2, so we're going to the left 1 and down 2, that's point number 1. And then our other point, 11, -7, so we got to go down 7, 1, 2, 3, 4, 5, 6, 7. And we've got those 2 points. Now, what we always want to find is when we're trying to find distance, we're trying to find the shortest measurement between the 2 values. Now, in order to find distance, what we have to do is turn this into a right triangle. And since we're doing horizontal and vertical lines, it's fairly easiest to find the measurements of these pieces. So here we have a measurement of 5, because we're going down from -2 to -7, and we're going from -1 to 11, so we're covering a distance of 12. And then we're just trying to find c, which is the hypotenuse value. So we know that c squared equals 12 squared plus 5 squared. And if I want c by itself, I have to square root both sides, 12 squared plus 5 squared, and then we square root that value to find our distance. So if we're going to find that measurement, we would have 12 squared plus 5 squared, okay, equals 169, and then we square root that value to get our distance between those 2 points of 13. So now, just making this one small adjustment, what we've just done here at this point is created the distance formula. Okay, and the distance formula, and we'll use it here in a couple times just to show you how it works. Okay, but the distance formula, or D equals, here is the distance between the 2 x values squared. That's one leg of your triangle. Distance between the 2 y values, that's the other leg of your triangle. And then just like we did in this example here, we have to square root to finish up. So now, let's try using the distance formula instead of using a triangle for this second piece. Okay, distance formula equals the square root, and what I have to do is subtract my x's. I can do it in any order. So I can do -9 minus 3. Okay, so we have to find the distance, but it is a subtraction to find the distance between those 2 values. We square it, and then we add the distance between the 2 y values. -6 minus 10 squared. So we want to go through and do a little simplifying. -9 minus 3 is -12 squared. And then -6 minus 10 is a -16 squared. Now, the good news is, even though that these values are showing up negative, when we square a negative value, we actually get a positive answer. So that's the nice part about squaring any of those values, is we can go through and we can have 12 negative, but when we square it, we get a 144. So now we can add 16 squared to that value, and we get 400. So then we square root the 400 to get the distance between those 2 points equal to 20. So the distance formula is just a extension of the Pythagorean theorem. If you have graph paper and you want to draw it out and use the Pythagorean theorem to find the distance, that is perfectly fine as well. That is a valid approach to look at and solve those problems. So now we can use this idea of finding distance, finding lengths, to determine what type of triangle we have. So to determine whether this triangle is scalene, isosceles, or equilateral, remember equilateral means 3 same sides, isosceles 2 same sides, and then scalene is all different sides. Okay, so as we work through, we're going to have to find the distances between these 2 points. So distance 1 between x and y, the square root of 13 minus 2. Remember, we can do the x's in either order when we subtract, plus negative 4 plus 2, because I'm subtracting a negative value, so that makes it a positive term. And then we're going to go through and finish. So distance 1, 13 minus 2 is 11 squared, plus negative 4 plus 2 is a negative 2 squared. So we've got 121 plus 4 for 125. Now, notice, I'm just going to leave this here. I don't have to turn it into a decimal value, turn it into any other value, because if I'm comparing lengths, I can compare them in their square root form. So I found length 1. Now I'm going to find length 2. Okay, so distance 2 is going to go between y and z, equals the square root of 13 minus 8 squared plus negative 4 minus 6 squared. So we've got the square root. 13 minus 8 is 7 squared. Oh, hold on, 5. Yikes. Okay, so we've got 5 squared plus negative 4 minus 6, negative 10 squared. So I've got the square root of 25 plus 100 equals the square root of 125. So now I've got 2 equal lengths. So I know it's not scalene. It's either isosceles or equilateral. So what I have to do to finish this problem is find distance 3, the distance between z and x. Okay, so we're working through square root. We've got 8 minus 2 squared plus 6 minus a minus 2 squared. So now we're finding this last distance, seeing if this is going to be a 125 as well. Okay, 8 minus 2 is 6. 6 squared is 36 plus 6 minus a minus 2 is 6 plus 2. That gives us 8 squared, or 64. So our distance 3 equals the square root of 100. So they're not all equal, but 2 of the 3 are equal. So we have an isosceles triangle in that situation. Now, finishing up with the equation of a circle. Okay, the equation of the circle is just like what we've seen before. And I'm actually going to go back and grab this grid paper so we can see what we're looking at here. I'm going to copy that. And we'll paste it here. Okay, so when we're looking at a circle always has a center and a radius. So the center of this circle is at 2, negative 4. And it's got a radius of 7. So what I can do to show where the circle is going to be, I'm going to do some easy counts. 1, 2, 3, 4, 5, 6, 7. So I know that that's an outer edge. 1, 2, 3, 4, 5, 6, 7. That's an outer edge. And then I can go up 1, 2, 3, 4, 5, 6, 7. And down 1, 2, 3, 4, 5, 6, 7. And what we've done is we've created this circle, okay, radius 7, with a center at 2, 4. And what we're actually doing in all of these situations is we're just creating right triangles. Central value, distance to a point. The radius is the one piece that never changes. That radius is always 7. So notice that this is basically building triangles as we go around. So that's why this looks very similar to the Pythagorean theorem. So we have x, because we don't know what the value is, we're going to have to find those values at times, minus our x central value squared, plus y, minus our y value of the center, equals our radius of 7 squared. And what we always want to do is we want to turn that into a whole number as quickly as we can. Okay, now, working backwards, what is the center and the radius of this circle? Okay, what we have to remember about our central values is it was a subtraction to give us the center. So if we're subtracting and we get a +2, we're subtracting a -2. If we're subtracting and we get a -5, the y value is 5. And then for our radius, remember our radius is the square root of 36, because 36 was equal to radius squared in the formula. So our radius value is 6 in this situation. Okay, that concludes our lesson. Thank you and have a good day.